everybody, and welcome to another Hyperight Data Talks. Today we're here with Serge Gershkovich, a product success lead at SqlDBM. Hello, Serge. How are you?
I'm great. Thanks. How are you doing?
It's great to hear that. To start with, can you briefly introduce yourself and share what your current working focus is?
Sure. So as you said, my name is Serge. I'm a data architect by trade, and I've spent the last few years working with SqlDBM, which is an online database modeling tool. We make a SaaS product that allows anyone in the organization to access, contribute, and self-serve data models, governance, and plan and build, and basically collaborate in real time on data modeling. And I guess the product success lead comes from me having a lot of time and opportunities to speak at interviews like this, at webinars, at events, but a lot of my time is pretty much dedicated to the product itself, to building out the tool, creating new features, and having that bridge between kind of what data professionals such as myself would expect out of that tool and our developers who help bring those features to life. I have a book out called Data Modeling with Snowflake, and it's been out for a year already, and it's done pretty well. So yeah, there's also that.
That's great to share with our audience, actually. Now, today's topic, I would like us to get more into decoding data modeling. So, can you define data modeling in the context of relational databases and explain its significance in the modern data stack?
Sure. Data modeling is really, it's as old as databases. It's from the foundation of relational theory and databases. Data modeling has kind of been a formal process of designing exactly what is going to be stored and what's going to exist in the database, and documenting a little bit of what it is, what the relationships are, what you can expect to find. And it's kind of evolved through time in the sense of it can describe not just what the actual physical database looks like, but also conceptually what the entities, what the attributes, what the relationships are between these things. And a lot of time the actual shape it takes within a database might be quite different from the entities that you would think about conceptually in your head when you think about your business, which business is really the key word that I think is most neglected when we talk about data modeling. Everyone in data tends to come from a scientific, computer science, engineering background, so they tend to focus on that technical aspect, the nomenclature, the semantics, the visual notations, when really it's just as simple as understanding what your business does and documenting it in an understandable way to, again, serve as that bridge between the business teams, the data teams, the analysts who are building the reports, the engineers who are creating the data pipelines to get that information through from source systems to data warehouse to dashboards typically. So it's just a way of making sure everyone stays aligned. I like to liken it to a map, basically. So everyone has a car, everyone does a lot of driving, but a car is only as good as if you know where you're going. And the map is really the data model of where do I need to go, which points along the way do I need to hit, and whether or not you have that map physically, digitally, or in your head, you always have a map. And even if you say, I'm just going to go out for a drive, you can still plot that on a map, even if it's completely random. There's always a data model behind whatever it is we do in in engineering, in anything data related. So if data exists, it has a shape, therefore it has a model. Whether or not that model is correct or understandable might be another point of discussion.
The analogy you mentioned is really interesting. And in what way does data modeling contribute to cost savings within AI implementation and AI maintenance also?
Great question. I would say data modeling goes back to the basic tenet of garbage in, garbage out. If you're dealing with data, as I just mentioned, you have a data model. The question is it a good data model or is it a crappy data model? Is it accurate or is it completely off base? And it's measuring before you cut, essentially. It's planning before you go. It's having something that you can draw on a piece of paper. It takes almost no work, and it's a little design that you can put in front of a subject matter expert, which tends to be someone from the business teams, because again, they understand. They might not know databases, they might not know SQL, Python, but they understand very acutely how how the business operates and which data it generates. Because again, we see data, it arrives, but it doesn't happen by accident. It happens as a result of pre-existing, predefined, very concrete business operations, sales, contracts, reservations, streams, what have you. And understanding exactly the business rules of these things is what really shapes the data model. So AI, ML, these are obviously garnering a lot of hype. There's a lot of potential there. But having been in the data industry for almost 2 decades now, it's very reminiscent of other hype cycles, which again, I'm not saying there's nothing there. Obviously, there's a lot of potential, a lot of things to be learned and capitalized on. But we've seen it before of people assuming data models don't matter. We've seen it with big data of schema on read. We don't need to invest the time. We'll figure it out. We have cheap processing, cheap storage. And now it's the same story, but just changed with AI. Like, oh, we don't need to data model because now AI will figure it out. We just keep kicking the can down the road instead of saying, well, why don't we just define it and agree that the definition is correct and then go? Why do we have to hope that something or someone will figure it out for us? So in my opinion, in my expertise, it really comes down to having something that you don't need to iterate and fix. It's all about getting it right the first time. It's all about feeding a coherent data set to your AI model, which then you don't have to even take the risk of, will AI understand it? Will it get it right? Will it intuitively sense that customer is the same as client, even though they're called customer and client, and one has a name, the other has 4-digit ID? Will it make those correlations? Maybe, maybe not, but why take the risk? So it really is, especially with engineering, I guess you can always test, you can always iterate on these, but with AI, that feedback loop is even longer. You don't know where the pitfalls are if it's made a mistake. You don't know what the conclusions are, and could they have been better? Are they as accurate as they can be? It really prolongs that AI ML life cycle, in terms of, why don't we just do it right the first time? And that's always been my stance, and it's been proven out in the big big data hype cycle, where schema on read is no longer a thing, and I'm pretty sure that with time AI will figure it out. Will also kind of get dismissed of, we need to understand exactly where we're coming from before we go out and we attempt to do something. There's no shortcut.
And beside the impact of data modeling on the cost savings. Could you elaborate a little bit more on how data modeling can ensure consistency in these AI-driven systems, and how can data modeling also help in avoiding rework?
Sure. In my perspective, again, it comes down to accelerating time to market. And time to market doesn't mean getting something out. It means getting a stable, getting the right thing out to market, something that doesn't need to be repaired constantly, tuned constantly. And this is what I was alluding to earlier with measuring before you cut. So sure, you can cut wherever and then see if it comes together, and maybe you'll get lucky, but chances are you won't. And it really does take the time. And I keep using analogies because I think there's almost no exception or no parallel where the converse is true. It's always think before you do, plan before you go, and maximize your chances of success ahead of time. So with the data modeling, there's really two versions of it, and sometimes they get blended together, sometimes one gets ignored in favor of the other. And just to separate out what I'm talking about, one is the relational data model, the other one is the transformational data model. And in that transformational, we can also include AI and ML, because again, that's just a type of transformation. It's a much more complex type, but that's still what's happening behind the scenes. So relational this is what we began with. The map of it essentially tells you what does your business consist of: customer, product, supplier, booking, whatever, what have you. And the transformational, these are all of the business questions of the analytics. How many customers last month? Which bookings have been made by these types of consumers? Or now we get into AI and ML projections of what's going to happen if we increase the price this much, or what are the biggest contributors to sales? These are open-ended questions that now you don't have a formula for. You're just hoping that AI will create for you. But they're very much intertwined. You can't do a proper analysis if your understanding of the pieces is incorrect. And this is what I was again alluding to earlier with garbage in, garbage out. If you're going to feed a bunch of data into an AI model without having really understood what it is, what it represents, it's very unlikely that AI will do a great job, especially considering that by definition you're asking more of it. That is not really, it's needless work that you're also asking on top of the predictions and analytics that you expect out of it to begin with. So it's back to maximizing rather your chances of success, minimizing rework, and making sure that what you end up with is as accurate as possible. Basically, you've ensured the most correct input possible, and the output again will depend on the nature of your analysis and your AI model.
You touched upon some differences between relational and transformational data modeling. I would like to ask you, what about challenges that might arise during the handoff between relational and transformational data modeling stages? And from your experience, how can one navigate these challenges effectively?
Great question. The handoff usually is, on one side it's technical, on the other side it's conceptual, because again, as a lot of our data teams, they tend to be a little bit siloed in the sense of ones who work on the source systems and ones who work on analytics in the data warehouse, data lakes type of space. And there's a very common kind of misconception on the data warehouse space that we don't need modeling, and we're just gonna figure it out. We're gonna build our DBT pipelines, and we're gonna iterate, and we're gonna change them, or we're gonna build our predictive analytics and iterate on that. So we don't need modeling. And that's almost like saying, again, if you get into the car and you drive to the supermarket, you don't need a map. But that's really not exactly true, because you do need a map. This map just happens to live in your head. You don't need to consult it. You're already familiar with it. Or maybe you're not. The bigger, imagine you walk into a shopping center and there's a directory in front of you. If the shopping center is maybe 20 stores, you can see them all. You might say, I don't need it because I can pretty much orient my way around, and I'll just keep walking and I'll find the thing. But if you're in Mall of America or something, and you're likely to spend 3 hours just walking up and down, hoping that you find the thing you're looking for, or asking questions along the way, these are the cost savings and the things that you want to avoid. Like, at a certain point, it becomes obvious, and at a certain point, it becomes trivial and unnecessary. But there's a spectrum where you're going to find yourself in this uncanny valley of, I don't have a data model, or I don't have a formal data modeling practice. Therefore, I'm going to call meetings. I'm going to ask people. I'm going to ask the guy next to me who helped me out last time. And you don't even realize how much time you're wasting. Or, okay, you didn't get it right the first time because you didn't know about certain data assets or attributes that existed, so you didn't include them in the report. Business complained, you went back, and it feels normal. There's nothing you did wrong. Whereas once you get a little bit up the chain on maturity and data literacy in organizations, you realize that all of these things have already been figured out. So the handoff between relational and transformational really comes down to how much of this, just like a data model, you can codify a lot with just a box or an arrow. There's a lot of meaning behind these little notations. How much of this can you codify between your, again, relational data model and your handoff to an engineer? Of what can you put into parameters, data contracts, something, for example, that DBT can understand in just a few lines. You don't have to explain and put these into phrases and like predefined tests, predefined checks, predefined freshness, things like this. And it's again, it's really all about economy and efficiency. Economy both in terms of information exchange, which is often verbal, which is often, again, images, pictures, emails, that once you standardize on a common form, you're ensuring that both people understand the same thing. And you, once again, if we're talking about putting them now in technical terms, now not only are you ensuring that your message is received, but that the system is then able to take that parameter file, that YAML file, or what have you, that data contract, and actually enforce to make sure that maybe you didn't understand me, the system will catch it. And whatever you build, the system can then fact check and validate for me. Therefore, I don't have to blame you, rely on you, hope, cross my fingers that you understood. All of these things, by following conventions, make it systematic to check, enforce, and just ensure data quality, which again sounds like it's a term that comes up over and over, but it's a very pernicious thing once it's lost, because it corrodes trust in the data teams, it corrodes trust in the technology, because end users, they're not as savvy technically as the data teams are. So they just know that the information they're receiving is late or slow or is incorrect. And it's normal that then they go off and they try to do their own analysis, or they go back to Excel, as everything inevitably ends up in Excel. And this is what we're really hoping to avoid by that following, taking the time to do things properly. So as they say in the military, slow is smooth and smooth is fast. And that's what we really want to ensure, is avoiding rework in the long term.
And what about the future of data modeling? How do you foresee data modeling evolving within the advancements in AI technologies and also cloud platforms?
Yeah, I think there's a lot of overlap there, of just like in coding in general. Again, when it was brand new, the hype was, okay, machines are going to take over. There won't be any more engineers. But we're finding that not to be the case. We're finding that a Copilot-enabled developer is just much more efficient than somebody working on their own. And it's not like Copilot will just take over and write complex code. You still need a human at the wheel to oversee. It just makes certain repetitive tasks much simpler. It makes certain boilerplate type of work much quicker or even instant. And there's a lot of this expectation of, oh, I can just go to ChatGPT and ChatGPT can draw me a data model of any industry or any business. And this is true. It can draw you a data model, but it can't draw you your data model because it doesn't understand the nuances of your business. But there's still doesn't mean there's not a lot of things that AI can't do for you. For example, generating meaningful descriptions. Again, if you prompt well enough with a good understanding of what each thing represents, generating tests where tests are needed, like where certain expectations, let's say, you have of your data, making sure primary keys are enforced and covered, things like this. So these are, DBT has done this really well. They've identified the points that are just completely repeatable, and they put it all in a parameter. And AI can go much further than that. So DBT again has, like, because it's programmatic, it's function based. It has to anticipate kind of what you want and what you can potentially feed into it. But AI can go a step further and say, well, there's not a predefined thing like for a general example here, but it seems to me like you should add this type of test or you should link to this other data set. And I just see it as a natural evolution, and I see modeling becoming easier. And I think there's a lot of reticence towards modeling has just been because of the repetitive nature of the activity. And if AI can put that on rails and automate it, then I think it's going to be in everyone's best interest.
Thank you for sharing your perspectives on this topic with our audience. And for everyone listening, I would say stay tuned for a presentation by Hazal Sener, who's a senior developer advocate at SqlDBM. And the presentation is titled Product Review with SqlDBM at the upcoming summit. And there's also going to be a workshop on mastering new age cloud database modeling with SqlDBM. And we are also proud to say that SqlDBM is one of our partners at this year's edition of the summit. So thank you once again for these answers, and we look forward to meeting the team at the summit.
Yeah, thank you very much. Thanks for having me. I had a blast at last year's event, and I'm sure this year is going to be much bigger and much better. Can't wait to see what you guys have in store for us. So thank you so much for taking the time.